All right, question number 48 says solve the inequality and write your solution in interval notation. Okay, so it doesn't appear that I have anything that I need to combine on the left or the right hand side. So I'm going to go straight to moving my variables. And as I mentioned on number 47, I like to move my variables to the left hand side. So let me I'm going to rewrite this over here. It's just so far away. So you work with these the same way you work with regular equations. The only thing is that if you divide by a negative, like I mentioned before, you have to remember to flip your inequality. That's the only real difference here in the way you solve it. So 7 minus 13 would give me a negative 6x plus 15 is greater than or equal to 51. And then I'm going to subtract my 15 over. So negative 6x is greater than or equal to 51 minus 15. Let's see. Don't know that off the top of my head. Sorry. Oops. 36. Okay. Now, here's where the pivotal moment is. We are going to divide by a negative 6. And because this is negative, I have to flip that the other direction. Okay. So I'm going to go ahead and write that over here since I ran out of space. So x is less than or equal to 36 divided by negative 6 would be negative 6. Okay, now, again, I like to draw the number line. I would encourage you, by the way, on these problems to always leave your inequality in the problem. I know some instructors tell students to, oh, just change it to an equal sign, and then at the end, put your inequality in. That's a terrible choice because when you divide by a negative like this, you wouldn't realize that you needed to flip your inequality. So, you know, just leave it in there and carry it down the same way you would an equal sign. You can treat it like an equal sign, sure. Just don't replace it with an equal sign. That's really bad form also. So, anyways, let's put our negative 6 here on the number line. Now it says less than or equal to. So less than means I am shading which direction? Well, I'm shading to the left again. And as I come up here to my negative 6, because I have that line, less than or equal to, that means I'm going to put a bracket here to include that value of negative 6. Okay. Now, again, it's not mandatory that you draw the number line. I just think it's really helpful to writing the interval notation. So your smallest value would be negative infinity, and then your biggest would be negative 6, and then you would put that bracket on there. So it flows very nice into the interval notation if you just graph the number line. Okay, number 49 says to find f of negative 3 for this function here. When you see function notation like this, this is giving you a replacement value for your variable. We did a problem very similar to this already. We just didn't use function notation and state that that's what it was. But this is just your replacement. F of negative 3 here is the replacement for all of your x's. So when I come over here to rewrite this, I'm going to put in a negative 3 in place of all my x's. This may look familiar to you if you watched the earlier parts of the video, because this is exactly what I did. I think I even used the same color. I just replaced all of these x's here with the negative 3, right? So that just tells you the replacement value for x. And because this is a function, then we know that when we input negative 3, we're only going to get one answer back out. That's one of the stipulations of being a function. That's the definition of being a function. Okay, order of operations. Negative 3 squared, you got to do exponents first. And so that's going to give you positive 9. And then we have the rest of our problem here. I'll just rewrite it. And then we are going to multiply. 2 times 9 is 18. And then negative 4 times negative 3 is positive 12 plus 5. And when we add all that together, we should get 35, if I'm not mistaken. So f of negative 3 equals 35. That would be my function value. Okay. Numbers 50 and 51 says find the GCF. So we're looking for the greatest common factor. In other words, what is the biggest number that you can divide all of these things by? Number or term, I guess. Could be a number and a variable. But I want to know, what do these have in common? So if I first look at the 2, the 4, and the 8, what's the biggest number I could divide those all by? Well, that would be a 2, right? Now, if I look at the variables, I have x cubed, x, and then a constant. So they don't all have an x in common, which means my greatest common factor is just 2. That's it. Apparently, that's all I'm doing on number 50. Oh, it says find the greatest common factor, but I'm looking at the answer key and they have it factored out. So I'm thinking the instructions are supposed to say factor out the GCF. So maybe we'll change this to say factor out the GCF. I'll fix that. Okay, so we're going to take, let me go ahead and put this back then, GCF 2. So that means we're going to put the 2 on the outside of the parentheses, and we're saying, okay, 2 times what gives me 2x cubed? Or in other words, you're dividing each term by 2, right? So if I divide that by 2, I just get 1x cubed. 4 divided by 2 is 2, and then the x is still there. Negative 8 divided by 2 would be negative 4. There we go. So that's all for that one. Okay. And then on number 51, we need to see what is the GCF here. So my greatest common factor for each of these things, well, I look at the numbers 3, 9, and 27. I can divide all of those by 3. Then I look at all my variables. I have x to the 4th power, x to the 2nd power, and x to the 1st power. Well, the most you can divide them all by is just x to the 1st power. So you take your smallest exponent, whatever that might be. So that's my greatest common factor, 3x. So I'm going to put that here in front of my parentheses. Say, okay, 3 divided by 3 is 1. You can put the 1 if you want. I'll put it. And then I've got 4 x's here. X to the 4th divided by x. Or in other words, I have 4 x's and I took one of them to the outside. So I still have 3 remaining in here. 9 divided by 3 is 3. I had 2 x's. I took 1 to the front, so I have 1 left in here. And then 27 divided by 3 would be 9. I had 1 x and I pulled it out to the front, so I don't have any x's left. So my final answer here would be 3x times x cubed minus 3x plus 9. Okay. All right, for questions 52 to 58, it says factor completely. So always look for a greatest common factor first, and then, move forward with how many terms do you have, things like that. So first thing I'm looking for is, do I have a greatest common factor among all 4 of my terms? The answer is no. They don't all have a number in common because this is a coefficient of 1, and this last term doesn't have an x. So we can't do a GCF on this one. However, we can do factor by grouping because we have 4 terms. So after you look for GCF, so GCF number 1, always do GCF first. Number 2, how many terms? Right? If you have 4 terms, you do grouping. So in this case, we have 4, so 4 means grouping. Okay, so we're going to group together the first 2, x cubed minus 5x squared. And then we're going to group together the last 2 here. Okay. And in my first group, I'm going to factor out my GCF from that group. So x cubed and negative 5x squared, I can factor out an x squared, which leaves me with x minus 5. And in my second group, I can factor out a 4, which leaves me with x minus 5. And then this is kind of the reverse of the distributive property, right? I have this x minus 5 here that was distributed to the x squared and the plus 4. So when I rewrite this all the way, like if I'm going, right, I'm undoing the distributive property, then I would have x squared plus 4 here, and then my x minus 5 would be here. Okay, you can think of it that way, that this is your That was the thing that got distributed to x squared and then plus 4. The other way to look at it is you're factoring out the x minus 5 from both of these terms. And your leftover things, x squared and plus 4, that's what goes here. Right? So if you want to do that, you know, you can write it in any order. It doesn't matter. You could have also done x minus 5 first and put x squared plus 4 second. These are the same. Hold on, I wanted to do this. Same. So it doesn't matter. Order that you put them in is totally up to you. So on the answer key, it is written like this first one here. I usually write it like the bottom one here. That's just my preference. But either way, totally your call, right? Your preference. I'm going to just box all of this to show that. Okay. On number 53, I'm looking for a GCF first, always. And I do notice that they are all divisible by 2. So there is a GCF. I'm going to start by factoring that out. So if I factor out the 2, then this leaves me with x cubed minus 2x squared minus 3x plus 6. Did I get that correct? 4 divided by 2 is 2, 6 divided by 2 is 3, 12. Okay, yeah, that looks good. Okay, now once you've factored out your GCF, you need to do factor by grouping with these remaining 4 terms. Because again, I have 4 terms, right? How many terms? 4. Do grouping. So leave the 2 on the outside, and I usually will put a bracket here instead of another parentheses just so that I can, I don't know, keep them all straight. But it's really up to you if you want to use double parentheses here. I just prefer to do bracket and then parentheses. Now when I'm grouping them together, you'll notice that there's a negative in front of that 3x. I always put a plus sign here in the middle, and then I put the negative with the 3x in the parentheses like this. And then that way, it's already, like, it's where it needs to be. If you leave the negative in the front here, you have to deal with it on both of these terms instead of just the first one. So some people do leave the negative out here, and then they just change the sign of the 6. You can do that. I just think that people tend to overlook that and make mistakes. So I'd say just always put a plus in the middle, and then take your sign with your numbers. Okay, so in my first group here, I can factor out an x squared, which is going to leave me with x minus 2. And in my second group here, because I want my parentheses to match, I noticed that that first term is negative. I should always factor out the negative with my GCF. So I'm going to factor out a negative 3, which is going to leave me now with a positive x. 6 divided by negative 3 would be positive, wait, negative 2. Sorry, I don't know why I said that. 6 divided by negative 3 is negative 2. There we go. Okay, and then your last step here is to then do the final factoring where you put your x squared minus 3 here, and then you put your x minus 2 there. Again, that was what was distributed. Now you notice that 2 is still in the front there, right? So you want to make sure that 2 is still there in your final answer. Okay. On number 54, first thing I look for is a GCF. And again, I do see that I have a GCF on this one. It looks like all the terms are divisible by 2, so I can put that there. So I'm going to go ahead and factor out the 2. That leaves me with t squared minus 14t plus, is that 48? That's 48. Yeah. Okay. Well, now that I've factored out the greatest common factor, the second question is how many terms, right? How many terms do I have? Well, I have 3. Okay, so depending on how many terms you have will determine, you know, what path you're going to take. Well, I have 3 terms. And so you have like 3 options. It depends on what your trinomial looks like. So do I have a number in front of the squared term? I mean, obviously not including the GCF, right? Ignore the GCF for a minute. But for the trinomial, do I have a number in front of t squared? And the answer is no, I don't. So I'm just going to set up my 2 parentheses. And so no number in front of t squared. So set up your two parentheses like this. Okay. So that's what we're going to do. We're going to leave this 2 still here, and we just set up our two parentheses. And we say, okay, we're undoing FOIL. I want to know what number times what, or what times what gives me t squared. Well, everybody says, oh, that's just t, right? T and t. And then I need to know what number or what numbers multiply to give me that 48, but they have to add up to negative 14. So multiply to 48, but they add to negative 14, right? And that's what's going to go here and here. So, you know, start thinking about your numbers. Well, I know that 6 and 8 multiply to 48. But if I want them to add to negative 14, I need them to be negatives, right? So negative 6 and negative 8. Does that work? It sure does. So negative 6 goes here, negative 8 goes here, and that's it. Now we're done. So it's a lot easier when that number in front of t squared is a 1. When I say no number in front of t squared, right, it's just a 1. Okay, so on 55, I first look for a GCF, no GCF. So then I say, okay, well, how many terms do I have? I have 3 terms, and there's no number in front of x squared, so we just set up our 2 sets of parentheses. Put my x here and here, and the reason I know that that x goes there and there is because I need 2 things that multiply to x squared, and that would have to be x. And then I'm looking for 2 numbers that multiply to give me negative 48, but they have to add up to negative 8. Let's see. So if I start going through my list of numbers, 1 and 48 isn't going to work. 2 and 24, that doesn't work. 3 and 16, no. 4 and 12, oh, 4 and 12, right? How about negative 12 and positive 4? Does that work? I think so, right? If I multiply them, I get negative 48. If I add them up, I get negative 8. Yeah, that works. So negative 12 and positive 4. You can always check this by foiling it out and making sure it comes back to the same thing that you started with. Okay, number 56, everybody's favorite. All right, so first thing, I look for a GCF, and see, I left a lot of space for this one. There's no GCF, right? 6, 7, and 3, they don't have any numbers in common. So, all right, we move to the next step, which is how many terms do I have? And I have 3, right? So, number 1, GCF. No. Number 2, 3 terms. So, what does this mean? All right, well, I told you there was several options. The first one is there a number in front of your squared term? And the answer in this case is yes. Since 6 is in front of x squared, then that means that we will do the AC method. Okay, so that's what we've now learned. If we have 3 terms, that's what we're going to do. Okay, so I need to figure out what is A times C, right? So A times C is 6 times negative 3, which is negative 18. And I need to look for 2 numbers that multiply to negative 18, but they add up to my middle term of 7. Okay, so if I start thinking 1 and 18 don't work, 2 and 9, okay, I think 2 and 9 are going to work in some form. One of them has to be negative. Well, if they have to add to a positive number, that means my bigger number has to be positive. So my 9 has to be positive, negative 2. If I 9 and negative 2, that adds up to 7, right? Negative 2 times 9, yeah, that's negative 18. Okay, so what we get from this information is really valuable. We know that negative 2x plus 9x then has to equal 7x, right? Would you agree with that statement? Hopefully you're sitting there going, oh, okay, sure. No, I hope you're sitting there saying, yeah, that makes sense. So if negative 2 plus 9 equals 7, then that means negative 2x plus 9x has to equal 7x, right? That's true, right? 9 minus 2 is 7. All right, we're good. Now, why do we care and why are we even doing that? Well, we care, and we're doing that because we want to take what has 3 terms here, and we want to make it have 4 terms. That way we can group and factor by grouping. So we've really done the hard part at this point. Now we just replace the 7x with negative 2x plus 9x minus 3. So I've just now taken this positive 7x here, and I'm replacing it with that equivalent statement that we wrote over here. So now I can group together my first two, 6x squared minus 2x. Put your plus sign in the middle, and then group together your second two. See, now it's just factor by grouping. So in my first group, I can factor out a 2x, which leaves me with 3x and then a minus 1. Right, negative 2 divided by 2 is negative 1. X came out. And then here I can factor out a 3. So 9 divided by 3 is 3x, and negative 3 divided by 3 is negative 1. Well, now my parentheses match, and we have 2x plus 3 here, and then the 3x minus 1 here. So you're done. See, that wasn't as bad as you thought it was. All right. Number 57. First thing, do I have a GCF? 9, 30, 25? I don't think so. No, it doesn't look like it, so no GCF. So the second question is, how many terms do I have? Well, I've got 3 terms. Okay, now I've got a number in front of x squared. So on the last question I said, all right, since 6 is in front of x squared, we should use the AC method. What I did not mention there is, because 6 is not a perfect square and it's in front of x squared, right? You should do AC method. In this case, I see this is like a special case, right? I've got a 9 in front of an x squared and I have a 25 here. So if you happen to notice that with your 3 terms, you have like some perfect squares here on the ends, perfect square, there's a chance that this might be a perfect square trinomial. And in that case, it's kind of special. So if you have a perfect square trinomial, then here's what you have to check. Okay, are the first and third terms positive? So, sorry, first and third terms, are they positive? And are they perfect squares? And so that's the first question you ask yourself. Well, yeah, first and third, those are both positive. Okay, check. Are they perfect squares? Yeah, those are perfect squares. Check. So now the next question you have to ask yourself is, okay, so if this can be written as something like this, right? So what squared gives me 9x squared? Okay, you would say, well, 3x. Ooh. Sorry, I forgot those. And then what squared gives me 25? 5, right? Okay, so now the next question you ask yourself is 2 times the 3x and the 5, does that equal my middle term of 30x? You ignore the sign. The sign will just tell you what you have to put in your final answer here, right? Okay, so is 2 times this thing equal to 30x? Well, let's see here. What's 2 times 3 is 6, times 5 is 30x. Check. Okay, so we've checked all of our requirements. There's 3 requirements. Those are the 3. And so if that is in fact true, then what you have is a perfect square trinomial, and this is what you do. You would write it this way. It's okay, 3x goes here, 5 goes here, square goes on the outside, and then what sign goes in the middle? A plus sign goes in the middle on this problem because this is a plus. So that tells you that sign there. So that's why I said you ignore the sign. It'll just determine what your final answer looks like. But this is a perfect square trinomial, and you can write it this way. Now, do you have to do that? Of course not. If you would like to do AC method on this, you can absolutely do that. The only issue with that is that 9 times 25 is kind of a big number. And I mean, it's not that big, okay? It's like, what, 225, I think. And then you're looking for what two numbers multiply to 225 and add to 30, and they'd be 15 and 15. So you can then still do this using the AC method if you don't really like this approach here. But if you notice the first and third happen to be perfect squares, it's likely that you have a perfect square trinomial. So, okay, number 58, do we have a greatest common factor? And the answer is yes. My GCF here is a 5. So I'm going to factor out my 5, and that leaves me with x squared minus, let's see, what's 180 divided by 5? 36. Okay, so now how many terms do I have? Well, I have 2 terms. And 2 terms, you're looking for a difference of squares, right? 2 terms, difference of squares. And so the question is this a difference? Yes, it's a subtraction. And are these 2 things perfect squares? Well, yes. So how would you factor this? Well, you say, okay, what square, actually, let me write this a little bit differently. Can you write this? I'm going to put that there. Like, what squared gives you x squared? Well, that would be x. And what squared gives you 36? 6. So you can then write this as x plus 6 and x minus 6. 1 plus 1 minus. Sorry, let me put this. So they have to have opposite signs. These are called conjugates of each other. And the reason you have the opposite signs is so that whenever you FOIL, the middle things go away. Like I get positive 6x and negative 6x. Well, that adds to 0. And that's why these have to be opposite signs. Okay. All right. Factoring, fun times. 59. For the following graph of f of x, determine f of negative 1. So come over to your graph here, and what this is asking you is when x equals negative 1, y equals what number? So I look on my graph. So, okay, x is negative 1 here, and I come up. My y value at that point would be positive 1. So that's it. F of negative 1 just equals 1. All right. State the domain and state the range. So, all right, let's see here. Domain is going to be your smallest x value to your biggest x value, right? Now I notice there's a solid point here on the left side of this graph here. So the smallest x value that gives me something on this line here is at negative 4. And it's actually at negative 4. So I'm going to put a bracket there because we do need to write an interval notation. And I have all these x values here giving me something on the graph. And because this one is an arrow, that means it's going to go on forever and ever and ever this way. So my domain is going to be everything from bracket negative 4 up to positive infinity. Now the range is going to be, so domain, these are your x values, right? Range is your y values. So we know domain, and so x comes before y, d comes before r, and therefore, you know, x and d go together and y and r go together. So for your range values, you're looking for the lowest point on the graph to the highest point because you want your smallest output value or smallest y value up to your biggest y value. Well, the smallest y value is right here at 1, and there's a whole bunch of them, so I'm going to put a bracket there. And then this arrow takes me up forever, ever and ever this way. So my range is going to be everything from bracket 1 up to positive infinity. All right, because this goes on to positive infinity up here. Okay. Number 60, from the graph, identify the domain and range in interval notation. So again, we're doing the interval, or I'm sorry, that's, yeah, well, okay. Not sure why we're doing it twice, but that's fine. All right, so we're doing the domain and range in interval notation here. So domain and range. So your domain, again, is those x values. So if you notice the arrow going to the left, that means forever this way. And then if I follow my graph over until I get to where it finally stops, which is here at +2. So for this one, the domain is going out to -infinity. So start with -infinity up to +2 with a bracket, because there's a solid point there. And then for your range, this is pointing down, meaning it goes on forever this way. And the highest point is not that solid point right there, but it goes all the way up here to where 4 is, right? And there's a bracket there. So this is -infinity. So the smallest output is -infinity, and it goes up to +4 with a bracket on it. Okay, number 61. Write the given numbers from least to greatest. Oh, well, okay. So I've got -1/7 is like the only negative number, so that has to obviously be first. Okay, and then I've got 2.5, 9, and 6.2%. Okay, so let me come over here. 2.5, 9, 6.2%. Now 6.2% is per 100, right? So that means 6.2 divided by 100. And if I do that, 6.2 divided by 100, I'm going to get 0.062. Okay, and then I have 2.5 and 9. So it looks like I'm going to put my 6.2% next, because that's smaller than 2.5. And then 2.5, and then 9. Okay. A bag of balloons consists of 7 white balloons, 5 yellow balloons, and 10 black balloons. What is the probability that a balloon chosen randomly from the bag will be black? Okay, first we need to know what's the total number of balloons in the bag. So the total number of balloons would be 7 plus 5 plus 10. So 7 plus 5 plus 10 should be 22. Total of 22. We have 7 white, 5 yellow, 10 black. Okay, so it says, what's the probability that it will be black? So we have 10 black out of a total of 22. And when we reduce this, it should be divided by 2, so 5/11. And it looks like we're going to leave as a reduced fraction, 5/11. Okay. Number 63 through 66 says to simplify. So we've got fractions here. Check on my time here. Okay. So in order to add fractions or subtract them for that matter, you have to have common denominator. I know that that's your favorite phrase, the LCD here. Okay, so least common denominator. So how are we going to figure that out? Well, I'm looking at 4, 14, and 7. So I need to know what is the least common multiple of those 3 numbers. So you can start by listing out the multiples if you like, and try and find it that way. But I think the easiest way is to write out your prime factorization and then find it that way. So like 4 you can write as 2 times 2, 14, 2 times 7, and then 7 is just, well, 7. And you want to you line them up here like this, right? And so, all right, you take down your 2 here, your 2 here, and then your 7 here. And when you multiply all those things together, that's going to be the LCD. So 2 times 2 is 4 times 7 is 28. So your LCD is 28. All right, now you can do that obviously without writing it out like this, but I think that that's helpful to do. The other way you can look at it is which one has the most 2's, you circle that, cross out the rest. Which one has the most 7's, circle that, cross the rest out. In the end, you still get 28. So I need to rewrite all of these with the same denominator. So negative 3 over 4, I need to multiply that by something that will give me a 28 in the denominator. And then for negative 1 over 14, I need to multiply that by something to give me 28 in the denominator. And the 6 over 7, I need to multiply that by something to give me 28 in the denominator. And actually, let me write those all. 28, 28, and 28. Okay. So that's what we have, 28. All right, so let's multiply 4 times 7. So I'm going to get negative 21 there. And then 14 times 2 will give me the 28. So negative 2 on that one. And then 7 times 4. So 6 times 4 would give me the 24 on the top there. All right, so once you have that same denominator for all your fractions, all you have to do is add up those top numbers. So my final answer here is going to be negative 21 minus 2 and then plus 24. All over 28. So what does that equal? Let's see. Let me type this in. Negative 21 minus 2 plus 24 is going to be a 1. 1 over 28. That would be my final answer. Now, whenever you rewrite this, let me write this here. 28. Whenever you combine your numerators, you don't add the denominators. The denominators stay the same. Okay, that stays the same throughout. Once you have the same denominator, then you keep that over here. Okay. So for this one, 6/12 plus 7/18, I need to find the least common denominator here. And I'll see, 12 is 2 times 2 times 3. And 18 is 2 times 3 times 3. And for this one, I'll do it the other way that I mentioned, where I say, okay, which one has the most 2's? And which one has the most 3's? That one. So my LCD here would be 2 times 2 times 3 times 3, which is 4 times 9, or 36. Right? That's my LCD. So I need to rewrite both of these as something over 36. So 6 over 12 times what equals 36 there. And then I have my 7 over 18 times what equals something over 36. All right, so for 12 times what is 36? That would be 3 over 3. And then 18 times 2 over 2. So 6 times 3 is 18. 7 times 2 is 14. So when we add those together, 18 plus 14, and then you keep your denominator the same, that's 36, right? Then what's 18 plus 14? It's 32. And in this case, we need to reduce that because it's not fully simplified. So 32 and 36, let's see, that is going to reduce to 8/9. So if I can divide them both by 4, I get 8 over 9. That would be my final answer there. Okay, we are on the last page. Okay, so 2/7 times 3/6. The good news is that when we multiply, we just multiply straight across, and then you can simplify it at the very end of the problem. That's how most students prefer to do this. I prefer to factor it, and then I can cancel out like one-to-one stuff. So I would write this as 2 times 3 over 7 times, and 6 I can write as 2 times 3, right? Now if I do that, well then I say, oh, this is like the fun part, right? I can cancel a 2 and a 2, which divides to equal 1. And a 3 and a 3 also divides to equal 1. So what do I have remaining? Well, I have on the top a 1 times a 1, which is 1. And then 7 times 1, which is 7. So my final answer would be 1/7. Now, alternatively, you can just multiply it straight across, and you would get 6 over 42. And then you just divide them both by 6, which would give you 1/7. So that's the other way you can do it if you prefer. Okay, for number 66, we're dividing fractions. And in order to divide fractions, you have to first rewrite it as a multiplication problem. So you keep the first one, change the sign in the middle, and you flip the second one. So keep, change, flip, if you recall. And then from here, it's the same as number 65. You know, straight across, multiply. It looks like actually there's nothing that can be simplified. So 5 times 7 is 35. 8 times 3 is 24. And this has nothing in common. So we just leave it as 35 over 24. All right, number 67. For the graph, state the coordinates of the intercepts. Okay, so like the ordered pairs, right? So we need to know what is the x-intercept and what is the y-intercept. In other words, where does this graph cross the x-axis and where does it cross the y-axis? So let's start with the x-axis. It looks like it crosses right here. And at that ordered pair, this is when your x is 3 and the y is 0. Okay. Now for your y-intercept, this is where it crosses the y-axis, and at that point, that's where x is 0 and your y-coordinate is 1. All right, state the slope. Well, now that we know the intercepts, we can actually find the slope between those 2 points. So we want to count rise over run. Remember that it's rise over run. So I always start on kind of the left point here, and I'll work my way over. So from here, let me get, I guess I'll get this. My rise is going to go down 1, so that's minus 1. And then I'm going to run 1, 2, 3. So my rise is negative 1. And then my run is 3. So this one down 1 and then right 3. Like that. Okay, so m equals negative 1 over 3. That would be my slope. Identify the domain and range in interval notation. Okay, well, this is easy. Domain, well, you see those arrows go forever to the left and forever to the right. That's everything. Negative infinity to infinity. And for that same reason, the range of this one is negative infinity to infinity, except that it's because it's going down forever and because it's going up forever. So both of those would be negative infinity to infinity. All right, number 68, find the slope of the line passing through the points 3, negative 1, and 4, 2. So I'm going to call this x1, y1, and x2, y2. So my slope formula is y2 minus y1 over x2 minus x1. So let's go ahead and plug them in. Now you can choose whichever point you want to be point 1 and which one you want to be point 2. I just choose them in the order that I see them. It's easier that way. So y2 is 2 and y1 is negative 1. x2 is 4 and x1 is 3. So just be careful when you plug in a negative after, or yeah, a negative number after a minus sign, that you don't accidentally combine the negatives. So here we end up with 2 plus 1, it's minus a negative, and 4 minus 3. So on the top we get 3, and on the bottom we get 1. Well, 3 over 1 reduces to just 3. So we'll just say m is 3. Okay, write the equation of the line with slope of m equals 5 that contains the point -2, -4 in slope-intercept form. So we can use the point-slope formula, which is y minus y1 equals m times x minus x1. And we know that the m here, actually I'm going to write it over here, m here is 5. And my point here is going to be x1, y1. Okay, so y minus y1, which is -4, equals 5 times x minus -2. By the way, this point-slope formula really just comes from the slope formula. You know, if you cross multiply this, that x2 minus x1, you cross multiply and put it up next to m, that's how you get this formula right here. So if you wanted to know, that way you don't have to memorize more than one thing. Okay, so y plus 4 equals 5 times x plus 2, because minus the negatives. Now we need to distribute that 5 here. So 5x plus 10. Subtract your 4, and where do we end up? Y equals 5x plus 6. All right. Cool, cool. We're almost there, guys. End of the last page. Number 70. Determine if the lines here and here are perpendicular, parallel, or neither. So if you recall, parallel lines have the same slope, different y-intercepts though. Different y-intercepts. And perpendicular lines are opposite reciprocal slopes. That means they have to have opposite signs and they have to be reciprocals of each other. Of course, neither would be neither one of those categories. So let's start with this first line here, y minus 4/7 x equals 3. We need to put this in the slope-intercept form, and that way we can identify the slope. So we got to get y by itself. I'm going to add 4/7 x to the other side. So y equals 4/7 x plus 3. Okay, so that's that equation. My other equation, 4y equals -7x plus 28. I need to divide everything by 4. So y equals -7/4x plus 7. So now let's look at our slopes here. These are my slopes, 4/7 and -7/4. That's not what I wanted. Okay, so m1 equals 4/7 and m2 equals -7/4. So what do we think? Are they parallel? No, they're not the same. Are they perpendicular? Are they opposite signs? Yes. And are they reciprocals? Yes. These are perpendicular lines. Such a long word. Perpendicular. Okay, last but not least, exponent rules. In fact, these are quite important moving forward. So, simplify and express using positive exponents. So I see here that I've got several things in the parentheses raised to the -3rd power. And what I like to do is I like to put a little exponent here on that number, -2. So that whenever I quote-unquote distribute that exponent, I hate to say it that way, but that's really what I'm doing, I have an exponent to multiply it by, because that's what you're doing. You take each of these things in here raised to this power. So I'll go the full steps here, and I'm going to write it as -2 to the -3rd power, and then x to the 3rd to the -3rd power, and y to the -4th to the -3rd power. Okay, that's what you're doing. You take each of those things raised to that power. And now when you get here, you have power to a power. So I have -2 to the -3rd power, which I'm just going to leave that alone for right now. And then here I have x to the 3 times -3 is -9. And then I have -4 times -3 is +12. Now, out of the things I have remaining here, only one of them has a positive exponent, so that one gets to stay on the top of the fraction. Everything else has to go to the bottom. So we have y to the 12th here over. Now I still have negative 2 there. That negative doesn't change. Only the sign of the exponent does. And then I have x to the positive 9th. Okay. Now the last thing is just to actually evaluate what is negative 2 to the 3rd power. That means negative 2 times negative 2 times negative 2, which would be negative 8 x to the 9th. Okay. You can leave it that way, or you can put the negative on the top, or you can move the negative to the front, in the middle. It's really your call. All right, last one, guys. We're almost there. Okay. We need to reduce, first of all, I've got two numbers here that can be simplified. 21 over 28. Those can both be reduced by a factor of 7, right? So, no, I have a good idea. I don't know. Let's do this. Let's write 21 as 3 times 7. And this p to the negative 4th needs to be moved to the bottom. So I'm going to write this 28 here as 4 times 7. And then I've got p to the 9th and p now to the 4th. All right, well now I can divide those. Cool. And my p's here I need to combine. So on the top of my fraction I still have a 3 remaining, and I have a 4 down here. But I should have p to some power. When you have two things with the same base that you're multiplying, you add the exponents. The reason for that is if we were to write this all the way out, we would have 9 p's and another 4 p's. So altogether, you would have p to the 13th power. And this is going to be your final answer there.